welcome to part 3 of my introduction to functions. In this one we're going to be looking at types like f minus 1 of x, g minus 1 of x. What does that mean? That means we're looking for the inverse functions. So f minus 1 of x is the inverse f function, g minus 1 of x is the inverse g function. So first of all then, what is an inverse function? Inverse functions are those that reverse the original function. So say that I started off with a number x and I added 2 to it. The inverse function, the function that would undo that, is to subtract 2. That would take me back to my number x. So we use this notation, f minus 1 of x. Be careful, that's not the same as saying f of x to the power of minus 1. That would mean 1 over f of x. Don't think of this minus 1 as a power. It's just here to tell us we're dealing with an inverse function. So before we get cracking on the examples, let's take the maths away. So say that we go to a shop and we use some money to buy a cake. Then think of that as our original function. Then what we could do is sell that cake for the exact same amount of money. Now selling the cake would be the inverse to buying the cake. But if we buy this cake for an amount of money, but then sell that cake for exactly the same amount of money, the inverse function is undoing the original function. Now thinking of it more mathematically, if our money is x and our cake is y, then the function turns x into y, then the inverse function turns y back into x. So let's have a look at some examples. So the first 2 I've already written out, and then the last 3 we'll go through together. So f of x is equal to 2x plus 1, find f minus 1 of x. So the first thing that we want to do is switch the function and the variable around. So everywhere where we've got an f of x, that becomes an x. And everywhere we had an x, that actually becomes now the inverse f function. So if we make that swap, we end up with x equals 2f inverse plus 1. And then step 2 here is to rearrange that to make f inverse the subject. So we subtract the 1, that gives us x minus 1 equals 2 lots of f inverse, and then we divide by 2. And that would then tell us that f inverse is equal to x minus 1, all divided by 2. There's our inverse function. Example 2. G of x is equal to x cubed minus 1. Find g inverse of 7. So we've got an extra step in here. We want to find the particular value of the inverse function. So first of all, let's find the inverse. So again, the function and the variable swap places. So g of x becomes x, and the x becomes the g inverse. So x cubed has become g inverse, all cubed. So that's left us with x equals g inverse cubed minus 1. Step 2, rearrange to make g inverse the subject. So we add the 1 to both sides. That gives us x plus 1 equals g inverse cubed. And then to get rid of that cube, we cube root both sides and get the cube root of x plus 1 is equal to our inverse g function. So then to find a g inverse of 7, we just substitute that 7 in as we would to a normal function. So g inverse of 7 is the cube root of 7 plus 1, which is the cube root of 8, which is equal to 2. Jobs are good. Okay, so for the last 3 examples, I'm going to work through with you as we go. So they're going to build up in difficulty, but let's see how we go. So, f of x is equal to 3x plus 5, all divided by 2. Find f inverse. Okay, so step 1, swap the function and the variable around. So that will give us x is equal to, let's put that back, x is equal to 3 lots of f inverse plus 5 all divided by 2. So that's the swapping part then. Now we need to make f inverse the subject. So the first thing we would do, multiply by 2, and we get 2x equals 3f inverse plus 5. Take away the 5, so 2x minus 5 equals 3f inverse. And then finally, for our last step, divide by that 3, and we will be left with 2x minus 5 all over 3 equals our inverse function of f. Jobs are good 'un. Okay, so these final 2 examples then are certainly getting on towards the tricky end of the scale. When we're working out the inverse functions, we're going to use a little trick with the notation just to keep it less cluttered and hopefully a little bit simpler. So first of all, let's read the question. H of x is equal to x plus 1 divided by x, where x is not allowed to equal 0. The reason it's not allowed to equal 0 is if x was equal to 0 here, then we'd be dividing by 0, and we can't do that, it's naughty. And we want to find the value of the inverse function when x is equal to 2. So given that the algebra is going to be quite heavy here, what we're going to do, and you're perfectly allowed to do this for any inverse question, instead of having to keep on writing h inverse, what we're going to do, we're going to say that y is equal to the inverse h function. So then instead of having to keep writing h inverse, we can just use a cheeky little y instead. So if we start off as always then, swap the function and the variable around, so h of x becomes x, and all the x's on the right hand side would become h inverse. But remember, we've set y equal to that now, so we can just write that as y plus 1 over y. So now we're trying to make y the subject of that. Let's have a look at how we would do it. So we've got a y on the bottom of the fraction. That's quite annoying. So first thing we're going to do is multiply by the y. That's going to give us xy equals y plus 1. Now we need to get the y's on the same side together. So if we take away a y, we'll get xy minus y equals 1. Okay, so now we've got a little bit of a problem. We've got 2 y terms. We can't combine them normally because one's got algebra attached to it. So what we do in this situation, we factorise. We've got a common factor of y here over on the left. So we can say that's equal to y lots of x minus 1. And then that's all equal to 1. And then finally we can divide by the x minus 1. And that will give us y is equal to 1 over x minus 1. So remember, at the start we set y equal to our h inverse. So that's saying h inverse is equal to 1 over x minus 1. Now remember too that we wanted to find the value of the inverse function when x was equal to 2. So if we substitute x equals 2 into that, we'll get h inverse of 2 is equal to 1 over 2 minus 1, which just leaves us with 1. So h inverse of 2 there is equal to 1. Cracking. Okay, then the last example in this video, and it's even more fun than the last one. So you very often get asked to rearrange algebraic fractions to change the subject, and you would get given 4 marks if we've got a fraction like this guy here, 2x plus 1 over x plus 2. So this is good practice for that as well. So here we've got f of x is equal to 2x plus 1 over x plus 2, where x is strictly bigger than minus 2. Find the inverse f function. So as we did in the last example, so that we don't have to write out f inverse of x a million times, we're going to do exactly what we did last time and set y equal to the inverse f function. So remember, you don't have to do that. It just cuts down on the writing and hopefully keeps it all looking a little bit clearer. Okay, so step 1, swap the function and x. So f of x becomes x. And then the x's on the right become the inverse function, which we have set to y. So x is equal to 2y plus 1 all over y plus 2. And now again, it's our job here to make y the subject of this bad boy. So step 1, we want to multiply by the bottom of the fraction, and that will give us x lots of y plus 2 equals 2y plus 1. Expand the brackets on the left. xy plus 2x equals 2y plus 1. Now we need to get the y terms together on the same side. So if we take away the 2y that's out on the right, then we'll get xy minus 2y plus 2x equals 1. Now we don't want that x term kicking around with the y's, so let's move him as well, minus 2x. That will leave us on the left with xy minus 2y equals 1 minus 2x. And now we've got that magic step again over on the left hand side. We've got two y terms, one's algebraic, one's numeric. The only thing that we can do is factorise. So we've got y lots of x minus 2 equals 1 minus 2x. And then finally, divide through by x minus 2. We get y equals 1 minus 2x all over x minus 2. So our inverse f function is equal to 1 minus 2x all over x minus 2. Jobs are good. Was this video helpful? If so, be sure to leave a thumbs up and a comment telling me how you get on. For any further information, you can follow me on Facebook and Twitter and send requests or any feedback you have. Search for Maths with Mouth. Cheers, guys.